In 2011, Facebook, with a variety of other industry partners, founded the Open Compute Project. The idea of the Open Compute Project was to create a community where various deployers and developers of data center technology could bring their technology and share the way that they have developed and deployed it with other members in the industry. The hope was that together, by sharing what we were learning, we would be able to drive innovation in the data center space at an even faster pace. Over the years, Open Compute has grown quite a bit, and we have seen a variety of meaningful hardware contributions come into it. One of the great powers of Open Compute is disaggregation. Disaggregation is the idea that as an operator, you can deploy the combination of hardware and software that suits your needs best. By doing so, when your workload evolves and morphs over time, you have the flexibility to adapt your infrastructure exactly as best fit for your needs without having to modify greater pieces of your infrastructure. However, disaggregation can also be challenging. One of the challenges with OCP adoption is the ability to bring the right software and hardware together. The power of disaggregation means you have the choice of hardware and software that best fits your workload, but it also means that you have to bring it together successfully. What we noticed within the OCP community was that some adopters were struggling to validate a software stack while also trying to figure out how they would fit the hardware into their infrastructure. In order to help them sidestep this challenge and evaluate the effectiveness of the OCP hardware as they were figuring out its fit for the infrastructure, we founded the Disaggregate Lab. In the Disaggregate Lab, we have a variety of OCP contributed hardware available to adopters to trial, and they can run their software stacks as well as their workloads on top and get to know the OCP solution and validate its effectiveness before they have completely converted their hardware infrastructure. When we first opened the Disaggregate Lab, we hooked up with a couple of partners from the industry in order to demonstrate a full stack working. The first partners that we worked with were Canonical and Red Hat, who demonstrated their solutions working on top of OCP gear. You can see our OCP rack right over here. When we opened up the Disaggregate Lab, Facebook contributed some of its own gear. And we also got help from our friends in the OCP ecosystem. Specifically, Silicom, Mellanox, and Wiwynn also contributed hardware.
Hi, this is Jay from Wiwynn US. So we're here to break down furthermore detail on our rack configuration. So on this rack, our top zoning, we're containing 2 U3 node setup, and then each node that we're able to put facing 6 hard drives in, and Bravo CPU with 128 GB of DIMM, and the NIC is Meslin dual port 25 gigabit. We also have a dedicated of the management port, which is 1 gigabit. For our middle zone, focusing on each individual nodes connect into one single tray of our NOCs. And each tray containing 15 drives total. And then the tray themselves with 12G of the SOX expander board and with hot pluggable feature phase in. As we can see now, the data light is still on. So we didn't interrupting any kind of data interruption here. So we are able to unplug the drive and wait till the drive calm down. So we'll be able to remove the drive and replace them. At this moment, our data line is still on. That's for hot pluggable features. So the bottom here, then we have our lighting project, which is J-box solution, and currently it containing still 15 of the NVMe Intel SSD drive in it, but we can also using the adapters facing the M.2 format, so we can have 60 of the M.2 NVMe drive to face into the solution. For the rack configuration, our engineer has a specific platform design phase in. On the top zone right here, then we're more focusing on container and job tracker with the 4 hard drives in, with the CPU, 128GB DIMM, and all these things being included in here. The middle one is more toward the Hadoop storage solution. And then right down here in this segment right here then is for high compute, and over down the bottom then, down here we have storage head, and then we'll have more detailed explanation within our presentation file.
Once we had the hardware in, we quickly got to work, and we focused on building a disaggregate storage software stack, demonstrating a variety of solutions from various major players in the storage ecosystem. The first software solution we tested was NetApp's ONTAP Select. We got it working on the Leopard compute servers and the Knox JBOD storage systems. Following that, we got to work with IBM Spectrum Scale's distributed storage solution, which we also had running on top of Leopards and Knoxes without any issue. We also had a number of flash-based solutions that we showed. Specifically, we had demonstrations from Accelero, Weka.io, and Hedvig running their software solutions on top of our Ava flash card, which is basically a PCI Express interposer to M.2s slotted into the Leopard compute server. Finally, we had Red Hat demonstrate their distributed storage solutions on our OCP gear as well. Specifically, they showed BlusterFS and SEP running on our Leopard Knox combination. We would like to invite more folks in the ecosystem to join us in the Disaggregate Lab to demonstrate working software solutions and to trial various cloud workloads. We are happy to share our space and look forward to the ecosystem growing and innovating even faster.